In an era where food preferences are rapidly evolving, vegetarianism and veganism have risen not just as dietary choices, but as lifestyle movements. With this shift, there's been a surge in demand for foods that offer the taste and texture of meat without the actual meat. Enter meat analogues, the innovative products bridging the gap between traditional meat dishes and plant-based preferences. At the heart of this revolution is a remarkable ingredient: textured vegetable protein, commonly known as TVP. Derived primarily from soybeans, TVP offers a protein-rich, versatile alternative to meat. Its ability to mimic the texture of various meats, from ground beef to chicken chunks, makes it a favored choice in countless vegetarian dishes worldwide. But TVP is not just about replicating meat's texture. It's also about offering a sustainable, efficient, and ethical protein source that aligns with the values of many modern consumers. As we delve deeper into the realm of meat substitutes and explore the culinary and nutritional wonders of products like TVP, we're not just witnessing a trend, we're seeing the future of food. So let's delve into the science behind TVP. Textured vegetable proteins are products that have been transformed from a flour-type material into one which has a meat-like texture. The resulting textured vegetable protein product provides chewiness and fibrous character. Soy proteins are the most commonly used base materials for textured vegetable proteins. However, cottonseed, corn, wheat, peanut, and similar proteins can be texturized. Two common methods for texturizing proteins are thermoplastic extrusion and fiber spinning. The extrusion process uses either soy flour or soy protein concentrate as the starting material. This process has a cost advantage. The spinning process uses isolated proteins as a starting material. In the extrusion process, soy flour is mixed with water, sodium chloride, and other ingredients. The mixture is passed under pressure through a cooker extruder. The product expands as it leaves the extruder die and forms a textured vegetable protein product. The size and shape of extruded material is controlled by the size and speed of the cutting knife on the extruder. The sized textured protein product is then dried and packaged for shipment. Ingredients such as colors, flavors, seasonings, and nutritional additives may be added to textured proteins used in the canning industry. Spun soy protein products are made by spinning isolated soy protein into fibers, much like spinning nylon. The spun fibers are produced by solubilizing isolated soy protein in an alkaline medium. The protein solution is passed through a spinneret to form fibers, which are coagulated in an acidic bath. The coagulated fibers are then stretched by a series of rolls moving at increasingly faster rates. Binders such as egg albumin are added to hold bundles of fibers together. Colors, flavors, and other ingredients similar to those used in textured soy flour may be added to make the finished product. The spun fiber-based products are more expensive than extruded products because of the more expensive process and starting material. For this reason, they are generally sold as meat analogues to completely replace meat in specialized markets. Spun soy protein analogues are usually sold frozen as ham, chicken, beef, fish, or bacon slices, cubes, bits, or granules. The extruded soy flour products and soy protein concentrate products are the ones most generally used to extend meat in canned meat products. They are also used to totally replace meat in meatless entrees. Textured vegetable proteins have a per protein efficiency ratio of at least 80% of casein. Soy protein contains all the essential amino acids, The amino acid lysine is present in substantial levels, and methionine is the first limiting amino acid. Methionine may be added to soy protein products to give a per value equal to casein. The processes involved in fabricating textured vegetable proteins provide an opportunity to incorporate essential nutrients into food products. The wide variety of textured vegetable proteins available in the market allows the food processor to use these products in many applications. The primary area of usage is in ground meat-containing products. Textured vegetable proteins may be used to extend or completely replace ground meat products. There are several different types of textured vegetable protein available in the market to be used with meat or as is. Following is a list of the available textured vegetable proteins. This type of textured protein is designed to be used in dry form for snacks and can be flavored externally regional flavors. Also, it is used to make high-protein snacks, like high-protein bars. When texturizing, these high-protein snacks should be crunchy or crispy, but not hard. Since these snacks are consumed in dry form, they should be resistant to breakage during processing. The most common raw material for making these types of high-protein snacks is soy flour containing 50 to 60% protein and 70 PDI. PDI, or protein dispersibility index, is the percent of total protein that disperses in water under standard conditions and which is correlated with the amount of heat to which soy flour is exposed during production. It is used to estimate the degree of denaturation of soy proteins. These snacks can be made with soy concentrate, containing 70% protein. For this purpose, soy concentrates should be the low solubility type or alcohol washed. Also, the protein content needs to be diluted to avoid overexpansion. As we increase the protein content of these snacks, the texture of these snacks will be affected. Meat extenders, produced from the extrusion processing of defatted soy flour, or flakes, and soy concentrates, constitute the largest portion of texturized vegetable food proteins. These types of products are mixed with meat for further processing, changing the properties of the meat. These products are characterized by a random spongy meat-like structure that imitates the chewy texture of meat when hydrated with water. These products are rehydrated to 60 to 65% moisture and blended with meat or meat emulsions to extend to levels of 20 to 30% or higher. They are typically purchased in a dry form, that means 6 to 10% moisture in sizes that range from small flakes or granules of about 2 millimeters up to large steaks that are 12 millimeters thick, 80 millimeters wide, and 120 millimeters long. Other shapes that are typically available are cubes, around 6 to 20 millimeters, and noodles. The products may be colored to mimic a particular type of meat. For example, caramel-colored pieces might be used to mimic a cooked red meat, and red pieces might be used to mimic lamb or a cured meat product. These products are hydrated during their transformation into a meat extender or a meat alternative. This hydration process typically requires 5 to 15 minutes in room temperature water and results in the dry product soaking up 1.5 to 3 times its weight in water. The absorption of water depends upon the raw material used for making textured vegetable protein. SMA is a type of textured product that remarkably similar to meat in appearance, texture, and mouthfeel when properly cooked. The SMA is characterized by a meat-like striated layer structure that imitates chunks of whole muscle meat. This type of product can be made in different sizes ranging from 6 to 20 millimeters depending upon the application. The density of SMA is much higher than that of chunk-style products. The only difference between meat analogues and meat extenders is how they are texturized by extruders. If available, it would be purchased as a dry product of 8 to 10% moisture. It could be colored to mimic the appearance of cooked red meat or cured meat. SMA usually absorbs at least 3 times the water of their weight when cooked in boiling water. To transform SMA into a ready-to-eat meat alternative requires hydration in water and flavors, which takes 15 to 20 minutes under boiling conditions or as much as several hours in cold water. About 1 to 2 times, the dry product's weight in water is absorbed by the dry SMA, which can then be utilized anywhere a diced meat product might be used, such as ready meals or canned products. Fibrous protein products are made using a cooking extruder coupled with specialized dye technology to form the continuous fibrous structure. These products are characterized by long strands of fine, silky fibers that run lengthwise throughout the piece. A typical recipe for making fibrous protein contains soy concentrate with high solubility, soy isolates with high solubility and high viscosity, and starch from corn or wheat. Fibrous soy protein formation is reliant on the use of specific, high-viscosity, soy protein isolates, vital wheat gluten, and starch. Fibrous soy protein products are generally available in chunks that are approximately 15 to 25 millimeters in diameter and 30 to 70 millimeters long. These chunks are available in a dry, that means 6 to 10% moisture, form and contain 50 to 70% protein. Fibrous soy protein products can also be colored with caramel color to mimic cooked red meat, or with red to mimic cured meats. Naturally colored products are very good for producing meat alternatives that mimic poultry or fish products. This type of textured protein is used to restructure the meat analog and mimic the chicken breast type of meat, approximately 15 to 25 millimeters in diameter and 30 to 70 millimeters long. These chunks are available in a dry form and contain 50 to 70% protein. High-moisture meat analogues are presently manufactured by several pilot and commercial extrusion facilities for human consumption as well as for the pet food industry. HMMA is designed to mimic the properties, texture, nutritional profile, flavor, and appearance of whole muscle meat, especially meat products that are very lean or have low fat content. HMMA can be made in various sizes, beginning at 12 millimeters thick and 80 millimeters wide. It has a densely layered and somewhat fibrous structure, similar to that found in whole muscle products. Typically, it contains at least 60 to 70% moisture, 2 to 5% oil, and 10 to 15% protein. Once it is made, it must be frozen for storage because of high moisture content, or retorted in cans for longer shelf life. Generally, it is available in chunks to imitate cubed meat or shreds to imitate pulled meat. Typical applications are prepared ethnic foods, frozen ready meals, and similar high-end consumer food items. A typical formulation of LMMA contains soy concentrates with high solubility, soy isolate with high solubility, wheat gluten, mechanically expelled soy flour, and oil from a vegetable source. The low-moisture meat analog is extruded with a twin-screw extruder using a special configuration and die to make a layered, fibrous structure that can mimic whole muscle meat texture and composition. This product is cut with an extruder knife, at the die, into the finished product size and shape, and dried after extrusion for ease of handling, storage, and shelf stability. In terms of size, LMMA can be made from 12 mm thick and 80 mm wide depending upon the application. This product is hydrated, with water, to make various meat items. After hydration, its composition is approximately 60 to 70% moisture, 2 to 5% oil, and 10 to 15% protein. Upon hydration, its structure is layered and fibrous, and sizes are very similar to whole muscle meat. After extrusion, LMMA is dried, cooled, and packed for storage. When needed, it is rehydrated and then flavored or coated with seasonings and flavors for consumption. The last TVP product is TMP. This type of product is processed with a twin-screw extruder using soy protein, mainly soy flour, and meat together to mimic whole muscle meat's texture and composition. The resulting textured meat protein is in small random chunks with a very fibrous and layered structure. In this product, low-end fresh meat can be a major part of the ingredients, up to 65% of the recipe. After extrusion, TMP can be dried, frozen, or retort packaged. TMP's sizes and shapes are very similar to pulled muscle meat and retort stable. Its major application is in canned pet food with some other meat applications. So, here is the brief overview of the textured vegetable protein. If you need any clarification, please leave a comment. Thanks for watching.